What is the most beautiful equation in mathematics?
So that's a very interesting question. So if you ask a mathematician what's the most beautiful equation, we have 1,000 answers. But the problem is we need to combine several nice mathematical constants into one equation, or then it's going to limit. So what we're going to do today, we're going to talk about a nice equation which has several interesting mathematical constants in one equation. So what are those constants? So let's talk about the first one. The first one I'm going to say E. So E is a what we call an irrational number. Irrational number means you cannot never write it until you will see the end of this one. So this is approximately 2.71828182. It never ends. So it's called irrational number. And why this is important? So for example, in a probabilistic point of view, so let's say there are several people. They're going to go into a room and then they're going to hang their hat in a dark room. Or leave, come back, and then they try to pick their hat. So what is the chance that everyone gonna pick the wrong hat? So the interesting thing is you can see that the probability of that happening is 1 over E. So this is one situation where you can combine a real world situation into a nice mathematical model. And what's the next important number? How about pi? So what is pi? Pi is, we know that it is 3.1415 like that. So how you combine, how you understand the meaning of pi? So you can see that, like let's look at this situation. So I'm going to draw a square. Now what we're going to draw? We're going to draw the largest possible circle inside this square. So if you try to draw largest possible circle inside this one, so I'm going to try my best to do it. So this is the largest possible circle that you can put inside. Now the question is, what is the ratio between this circle, or the area of the circle, or the ratio between the area of the circle and area of the square? So we're gonna get the whole square. So what's the area of this? So we're gonna look at the ratio between the two. So if you try to find the ratio between these two to the circle, to the square, and you can see that that is exactly pi. So it's kind of interesting how those two are connected. And we also understand that the pi is a universal number. So it doesn't matter whether we live in this world or another world, we still have the same pi involved. The ratio between the circle to the square is still pi. So what's the third important number? So let's talk about the I. So there's an interesting number called I in mathematics. This is what we call the complex unit. So but we know that, like, when you square a number, it is positive. So if you square 2, it is 4. If you square negative 2, that's still 4. So now there's a question, can a number, when you square, you get a negative number? So you can see that in the real numbers that cannot happen. But what some mathematicians did was, they kind of introduced a new idea called complex numbers. So what's going to happen with complex numbers? You know that there's a complex I. So when you square I, what we're trying to do is gonna equal to negative 1. So it looks like kind of crazy idea, but it has a lot of applications. For example, an engineer cannot do their calculations without those numbers. A computer scientist cannot understand certain things without those numbers. A physicist cannot do most of their work without this complex I. This is in chemistry, it's in biology, it's everywhere pretty much. So it looks like weird, but there are a lot of applications. So, and then once you take the square root of this number, we're going to get what we call the complex unit. So it's a negative 1 square root. So that's how we write it. So, but be careful, don't try to kind of focus on that too much. What you need to focus on is I squared equal negative 1. Well, so that's the third important number. And then we have more. How about 1? What is 1? 1 is a really beautiful number, and it's also very important. For example, when you multiply 2 with 1, it is 2. When you multiply negative 3 with 1, it is negative 3. So what happened? Nothing happened pretty much. When you multiply, you get the number itself. So that's what we call a multiplicative identity. When you multiply, you get the number itself. So this is what we call the multiplicative identity. Multiplicative identity. And then there's another interesting number. So what's the next interesting number is 0. So you see that 0 is nothing. It's not really. Without 0, we can do most of the things. For example, if someone asks, what's going to happen if you do this calculation? So if you don't know anything about 0, you don't have an answer for that. What are you going to say? I don't know. No, that's not the answer. So we know that when you try to add 2 with negative 2, what's going to happen is it's going to annihilate and you end up getting 0, like disappear. So that's what we call the additive identity. So when you add the 2, you get a number, and that number is the additive identity. So it's additive identity. Additive identity. Additive identity. So there's no A. Additive identity. Now the thing is that, can we combine all these into one equation? So that's the interesting part. Actually, the answer to that question is yes. We can combine all of these into one nice equation, and the equation we can write it like this. So it is E, I, and then pi equal plus 1 equals 0. So E, I, pi plus 1 equals 0, and this is what we call the most beautiful equation in mathematics. And this equation is called the Euler's equation. It's called Euler's equation. Euler's equation. So I'm going to write it like that. This is called Euler's equation. So this Euler's equation is a result of what we call the Euler's identity. And then when you evaluate the identity at pi, you end up getting this equation. So this is what we call the most beautiful equation in mathematics.